Hi guys, this is Paul with TweakTown. We're sitting down with Vijay Meduri, the Executive Vice President of Engineering here at PLX Technology. And PLX has a long history in the computing space. If you could give us a little bit of your background and some of the things that you guys have already been doing.
So PLX is a fabless semiconductor company, and we've been public since 1999. And over the years, we've done a lot of I/O interconnect products. And off late, we've been focusing on PCI Express as our main interconnect around which we're building several families of products. And the switches are something that we focus on. And most recently, we've been working on enhanced switch functionality around PCI Express.
So your products are already integrated into just about every motherboard PC component that is deployed in enterprise and even in consumer applications. And right now, a big product of yours that's coming forward is the Express Fabric. Can you give us a little definition or explanation of the Express Fabric?
Yeah. So if you go back, a decade, PCI was a main I/O bus interconnect. You open a PC and you see a PCI bus. PCI Express is the natural evolution of PCI. And the bus became into a fabric or into an I/O interconnect once it went from a parallel bus interface to a serial interface. Now you have SerDes that are doing most of the data transfer. Now once it has gone serial, though there's a lot of legacy involved and people are used to a single host and a bunch of I/O devices, what we've seen is with the enhanced bandwidth and the feature set of serial links, a lot of our customers in PCI Express Gen 2 and Gen 3 have been asking for larger topologies. They want to do multiple hosts. They want to do clustering. They want to do more I/O sharing. And as we looked at all these features, we kind of all rolled all those enhancements into something that we call Express Fabric. And once we got to looking at the Express Fabric hardware solution, it became very clear to us 3 years back, that the key is software. As long as we make all the applications run seamlessly, there'll be very little resistance to accept the technology because the people already use PCI Express. They have the ecosystem, they have the debug equipment, they're very familiar with it.
And so this would allow PCI Express to kind of break out of the box and provide that interconnect between different computers or servers, in this case, instead of using Ethernet or fabric, or an Ethernet fabric, correct?
Yes. So when we say break out of the box, that was kind of a simplified way to give the message. But the reality is, with some of the highly dense boxes that you see today, you could really put in a lot of compute within a 2U chassis or a 3U chassis. Even in those topologies, you could really use Express Fabric to build a small cluster with 20 nodes, 40 nodes, 80 nodes. But outside the box is something that we've been explaining to the market to simplify that. Within the box is fan out, outside the box is more fabric kind of features.
And how will this work with the existing hardware infrastructure? If someone was to come in and change their deployment over to this type of an architecture, how hard would that be for them?
So what we've done is, if you look at the standard CPU architecture today and the I/O interconnect architecture, PCI Express is already used. What happens is it gets to a NIC, and then there's a PCI Express to Ethernet bridging going on. Or it goes to an InfiniBand HBA, which is PCI Express to IB, or fiber channel. So all we had to do is, as long as we keep the software discovery semantics the same, then all the applications will run seamlessly. And that's what we've been doing the last 3 years. We've essentially built into the device DMA engines that essentially make the software applications run seamlessly.
So that will allow a seamless, transparent integration of this into existing systems.
Yes, and one of the key things with PCI Express is, it runs all legacy PCI compatible software. And the reason PCI Express is so successful is because all the legacy applications ran. It's the same architecture we are taking forward where, or the same emphasis to backward compatibility we're taking forward, where we want to make sure all Ethernet applications run seamlessly, all IB applications run seamlessly. As long as we keep it simple, we think the uptake will be very easy for our customers.
I think one of the most interesting aspects of this technology is it could create almost a sea change in how resources are deployed in the data center. Right now we have CPU, RAM, storage, everything right in a box. If you want to replace or enhance any one of those components, you typically replace the box. How would this change that?
So the disaggregator server is something that a lot of people in the industry are pushing for, where they want to change the CPU, they want to change the I/O cards at a different upgrade cycle, and not all be linked together. And the Express Fabric technology essentially allows you to do that. The various ways to implement a disaggregated server, and the Express Fabric is, we think, one of the most efficient ways to do it, still using all standard cables and standard software stacks.
And I think that makes a lot of sense with NVMe applications and flash. A lot of people are concerned about essentially having that flash on an island inside of a server.
Yes.
And this allows you to share that among the whole rack, correct?
Exactly. Flash is an expensive storage media, and if you look at the application space, you do get application performance increment up to a certain point, beyond which just adding flash is, you're just wasting your capex dollars. So what this allows, if you look at a traditional rack server, if you give a shareable SSD storage, essentially you are making that costly resource accessible to all the servers, and you get more efficiency out of that shareable resource. And with the advantage of sharing, you can also reduce the power consumption in the rack server. You don't have to dedicate an SSD drive for every server in the rack. You can share it across the rack.
And I think lately, a big driver of change in the data center has been the Open Compute project. There's a lot of noise coming around it because they are changing the rules. And we're seeing a lot of ODMs getting involved. And in general, the architecture is changing. How do you foresee your involvement in that type of architecture?
So Open Compute is music to our ears. I mean, it really allows the power of our architecture to penetrate a lot of usage models. And some of our requirements in our product line have come from the large cloud usage models, where they are really looking at reducing the power consumption within the rack. They want to share I/O resources, and they also want to disaggregate the key components of a rack server. What the Open Compute initiative does for the industry is it allows a lot of customization. So it allows people to customize and build their compute resources in the most efficient form for their specific usage model. And the current paradigm of designing one specific box for a large number of use models, or a subset of models for a large number of use models, is kind of being turned over, where you can essentially build customized servers for the specific use models.
And that will also enable a lot of change. What we're going to do now is we're going to head to the lab and actually take a look at a demonstration. And we appreciate your time. Thanks, Paul.
Thanks, Paul. Thanks.